Okay, this is continuing on in section 3.2. And this is the leading coefficient test. Remember, standard form for polynomials is where terms are arranged from largest power down to smallest power. Assuming it's in standard form, your first term is going to be called your leading term. So leading term is when the terms, first term when terms are arranged from largest power down to smallest. Then we have leading coefficient. This is the coefficient of the leading term. Now I'm going to refer to this as COEFF. Or to say coefficient. And remember from last time we had a degree, which is our largest power of x. And if it's in standard form, your degree is the power of that first term. So everything is based upon the first term. So for our leading coefficient test, this is a test. It tells us what is our graph doing as it goes clear to the left, what's it doing as it goes clear to the right. Now we can have a positive coefficient, or we can have a negative coefficient. We can have an even degree, or we can have an odd degree. Now, if we have an even degree and a positive coefficient, like y is equal to x squared, then that's going to tell us up to the left, up to the right. Now, this doesn't tell us anything about what's happening in the middle. All this is telling us is what's doing clear to the left, what's doing clear to the right. Now, if we have an even degree and a negative coefficient, like y is equal to negative x squared, that'll be down to the left, down to the right. If we got a positive coefficient and an odd degree, like y is equal to x to the third, this is down to the left, up to the right. And if we got a odd degree negative coefficient, like y is equal to negative x to the third, this is up to the left, down to the right. This is an important test if you're graphing these by hand. It gives you a very important piece to understanding and saving you work. If you're using a calculator, it's somewhat important, but not as important. Okay, so for this problem here, they want us to match the function to the graph. Now, if I look at my function up here, our first term, our leading term, is x to the third. The coefficient is a number in front of that, which is a positive 1, and then it's an odd degree, so odd power. So we're looking at a positive coefficient and an odd degree. Well, you look where they intersect, and that tells us that our graph should be down to the left, up to the right. So I'm going to go look at my graphs and see which one's down to the left and up to the right. Can't be this one. This one's up to the left. What did I say? Down to the left. Okay. Yeah, this is up to the left. B, down to the left, up to the right. Down to the left, up to the right. So B would be our graph. Now this next one says use leading coefficient test to determine the end behavior of the graph of the polynomial functions. This is the standard form where your terms range from smallest or from largest power down to smallest power. Our leading term is this first one, the negative 5x to the third. The coefficient is negative. The power, the degree, is odd. So I'm looking at a negative coefficient and let's see, negative coefficient right there. And I'm looking at an odd degree. So that tells us our answer is up to the left, down to the right. I said it's semi-important if you're using a calculator, because if I were to graph it, and let's say this is what my calculator shows me. It doesn't show me the arrows, but so that's what my display shows me. I might think that's my graph, except for this would say, no, it should be up to the left, down to the right. What that means is this has to turn around at some point and come back down. So that means that there's more to the graph I'm not seeing. So that's where you use it in TA3, TA4. That's about its only purpose for TA3, TA4. It's a little bit bigger. Now these next problems ask us to find a few different items. So we'll talk about those as we work the problem. So we got number 10. F of x is equal to 2 times x minus 3 times x plus 1 squared. And the first instruction in this problem says to find the zeros for each polynomial function. Now, how we're going to find the zeros is you take your function and you set equal to 0. And then you'd solve this. You'd factor it if you could, which this is already factored. Then you'd set each factor equal to 0. So x minus 3 equal to 0, and x plus 1 is equal to 0. And solve it, and we get 3 and negative 1. And those would be our zeros. Second thing they're asking in the problem, it says give the multiplicity for each 0. Multiplicity was a movie. I think it was with Michael Keaton. Clever movie. He was getting tired of working, so he went down and had a clone made of himself. And the clone went off to work, and he went and played golf and had fun all day long. And he was married, and his wife got a promotion or something, and he had to take care of the kids and do all the stuff around the house. And he didn't want to do that, so he had another clone made of himself, and that clone took care of the house. So he had a clone taking care of the house. He had a clone going off to work, and clones got tired of their own work, so they had a clone made of themselves. And a clone of a clone is not mentally correct. This is a pretty funny movie. Movie is called Multiplicity. How many of them do you have? Well, it goes back to our power up here. See how this x plus 1 has a second power? That has a multiplicity of 2. This x minus 3, if I were to put a power on it, has the first power. So that has a multiplicity of 1. Now, the last thing they're asking is state whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. So crosses or touches. Now, if you got an odd multiplicity, that means it crosses. If you got an even, that means it touches. So that one crosses, this one touches. What does that mean? Well, if I were to multiply this through, or take the first term of each and think of it that way, we would see that this is going up to the left, down to the right. And at negative 1, it's going to touch. So this is going to be a touch. At 3, it's going to cross. So that's going to be crossing. So if it's going up to the left, it's going to come down here. It'll touch at this point, turn around. And at some point, it has to turn back around because it has to come over here to cross. Now, this will give us a pretty good idea what our graph looks like, except for we don't know how high up this one goes or how low it goes. So we'd have to plot one point. So that's why using the leading coefficient test and this information together helps you to get a picture of that without plotting 25 points. Okay, let's take a look at number 11. So we've got f of x is equal to x to the third plus 3x squared minus 4x minus 12. And want to find the zeros again. So remember how we find the zeros is you set it equal to 0. We want to solve this, so we're going to factor it. It factors by grouping. Group first two terms together, group last two terms together. First two terms have an x squared in common. That gives us x plus 3. Last two have a negative 4 in common, and that gives us x plus 3. Remember, our goal in grouping is we want those two parentheses the same, which they are, so I can factor it out. And that gives us x squared minus 4. Now, x squared minus 4 is the difference of two squares, so this factors as x plus 3 times x plus 2 times x minus 2. And zero factor property, you get 0 on one side, you factor the other side, you say each factor equal to 0. So I got x plus 3 equal to 0, x plus 2 equals 0, x minus 2 equals 0, which gives us negative 3, negative 2, and positive 2. And those will be our zeros. Now, multiplicity. If I were to put power on these would all be the first power. So multiplicity in all three of those is 1. That's how many times it repeats. And since they're all odd, that means that this all crosses. It means that if I was graphing this by hand, let's see, negative 3, 1, 2, 3, negative 3 here, negative 2, and positive 2. Leading coefficient test, since it's a positive coefficient and an odd degree, would tell me up to the left, down to the right. It crosses at all of these, which means if it's going up to the left, it's going to look like this. At some point, it turns back around, so it can cross here. And at some point in time, it has to turn back around, so it can cross over here. What I don't know is how far down this goes or how far up this goes. So I'd have to plot probably 2 data points to get a true picture of it if I was doing it by hand. Okay. Now this one wants us to graph it. Now I'm not gonna do it by hand. I think you kind of get the idea from those 2 examples I showed you. To graph this, we're going to use our calculator. So go to y equals clear x caret 4 plus x caret 3 minus 6x squared, and graph. I recognize that these won't necessarily show you the entire graph on the screen. I'm fine with that. So you just sketch down what you see for your standard display, and that's good enough. Okay. Close that. Let's go on to 3.3. Yeah. Is it? Yeah. Yeah, sometime next week. I just can't remember when I put. So. Dividing polynomials, remainder, and factor theorem. Mainly because I didn't want it to collide with the midterm on Wednesday. So. Yep, next class. I'll talk more about that toward the end of class. Okay, divide using long division. So we got x minus 4, x squared plus 2x minus 24. Now with long division, you look at first term of each. So I'm going to look at the x and I'll look at the x squared. And you ask yourself, what times x gives you x squared? That'd be x. Now, whatever you put up on top here, you're going to multiply by what's out in front. So x times x minus 4, distributive property. X times x is x squared. X times negative 4 is negative 4x. Then we're going to subtract this line, which means we'll flip signs. This positive x squared becomes a negative. This negative 4x becomes a positive.
How did you get what you have out of the
problem? What is dividing by always goes in front.
Okay.
And then,
sorry.
Oh no. Now x squared minus x squared cancels away. 2x plus 4x is 6x minus 24. And then we repeat the process. You look at the first term of each, side what goes up on top. You ask yourself what times x gives you 6x, and that'd be 6. Always what you put up on top, you're going to multiply by what's out in front. So I'm going to take 6 times x minus 4. That gives us 6x minus 24. Now we're going to subtract that line, which means we'll flip signs. So 6x becomes negative, the negative 24 becomes positive. A lot of you will do that step in your head. I can't show you steps in my head on the tablet here very well, so I'll write that out. So 6x minus 6x drops away, negative 24 plus 24 drops away, gives us 0. And our answer will be x plus 6. Take a look at another example of that. X minus 2, 2x to the third, plus 10x squared, minus 3x, plus 1. Again, we look at the first term of each, side what goes up on top. So I'll look at x and 2x to the third, and I ask myself what times x gives me 2x to the third, and that'd be 2x squared. Whatever we put up on top, we multiply by what's out in front. So take 2x squared times x minus 2, which gives us 2x to the third minus 4x squared. We're going to subtract that line, which means flip signs. So that becomes negative, this becomes positive. 2x third minus 2x third drops away. 10x squared plus 4x squared is 14x squared. And depending upon who taught you division, I was taught to bring everything down. Because then it's like a brand new problem to look at each time and not have to even consider anything up above. Okay, so we start over. We look at the first term of each, decide what goes up on top. You ask yourself what times x gives you 14x squared. And that'd be 14x. Whatever you put up on top, you multiply by what's out in front. So 14x times x minus 2. That gives us 14x squared minus 28x. I'm going to subtract that line, which means flip signs. So it becomes negative, this becomes positive. $14x squared minus 14x squared drops away. Negative 3x plus 28x is 25x. And I'll bring down plus 1. And again, we look at the first term of each side, what goes up on top. We ask ourselves what times x gives us 25x, and that'd be 25. So we'll take 25 times x minus 2. Gives us 25x minus 50. We're going to subtract that line, which means flip signs. So it becomes a negative. This becomes a positive. 25x minus 25x drops away. 1 plus 50 is 51. Now the degree of this is 0. You just got a number, you don't got an x, and the degree is 0. The degree of this is 1. X to the first power. When the degree of this is less than what you're dividing by, this is always a remainder. And how we write it is we put a remainder over what we're dividing by. So put 51 over x minus 2. And that'll be our answer. Got one more division, but is there questions on so far on that? Okay, got x to the third minus 2 x to the fifth minus 3x to the fourth plus 5x to the third plus x squared. Same instructions. Now, two things have to be true for you to use long division. Both what's out in front and what's underneath must be in standard form. These are in standard form already. Range from the largest power down to the smallest power. And you need to put 0 placeholders for missing powers. Some people teach leaving spaces, and that's fine too. For example, what's out in front? We got x to the third minus 2. I'm missing the x squared and I'm missing the x. So I'm going to put x to the third plus 0x squared plus 0x minus 2. And what's underneath? I got an x to the fifth, x to the fourth, x to the third. I got an x squared, but I'm missing my x, so I'll put a 0x, and I'm missing my constant term, so I'll put a 0. Now, some books, some teachers teach just putting it underneath. They don't teach putting it out in front. If you're learning it for the first time, it's beneficial to even put it out in front, because then everything lines up perfect. What the goal of this is so you like terms line up in the same column, and it just works out a lot nicer. And then we're going to do what we've done before. You take a look at the first term of each side, what goes up on top. You ask yourself what times x to the third gives you x to the fifth. That'd be x squared. Now we're going to take that x squared, we're going to multiply it times what's out in front. X squared times x to the third is x to the fifth. X squared times 0x squared is 0x to the fourth. X squared times 0x is 0x to the third. X squared times negative 2 is negative 2x squared. Again, notice that the like terms are in the same column now. That is our goal. We're going to subtract this line, so we'll flip signs. So it becomes a negative, 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 positive. X to the fifth minus x to the fifth drops away. Negative 3x to the fourth minus 0x to the fourth is negative 3x to the fourth. 5x to the third minus 0x to the third is 5x to the third. X squared plus 2x squared is 3x squared. And I'll bring down my 0x and 0. Again, I'll look at the first term of each, decide what goes up on top. We ask ourselves what times x to the third gives us negative 3x to the fourth. That's negative 3x. Whatever we put up on top, we're going to multiply by what's up in front. Negative 3x times x to the third is negative 3x to the fourth. Negative 3x times 0x squared, negative 3 times 0 is 0. X times x squared is x to the third. Negative 3x times 0x, negative 3 times 0 is 0. X times x is x squared. And negative 3x times negative 2 gives us a positive 6x. We're going to subtract that line, which means flip signs. Plus, minus, minus, minus. Negative 3x to the fourth plus 3x to the fourth drops away. 5x to the third minus 0x to the third is 5x to the third. 3x squared minus 0x squared is 3x squared. 0x minus 6x is negative 6x, and then I'll bring it down to 0. Then we'll look at the first term of each side, what goes up on top. We ask ourselves what times x to the third gives us 5x to the third, and that'd be 5. 5 times x to the third is 5x to the third. 5 times 0x squared is 0x squared. 5 times 0x is 0x. 5 times negative 2 is negative 10. We're going to subtract that, so we'll flip signs. So that's negative, 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 positive. 5x third minus 5x third drops away. 3x squared minus 0x squared is 3x squared. Negative 6x minus 0x is negative 6x. 0 plus 10 is positive 10. Now this is a degree of 2, isn't it? Which is less than what we're dividing by. So we're going to take what our remainder is. 3x squared minus 6x plus 10. And we'll put it over what we're dividing by, which is x to the third minus 2. And that's our answer. Any questions on long division? Now, this next topic is synthetic division. And long division, if you don't know it, it's not a huge deal. If you don't know synthetic division, then you'll fail the test over this chapter. Because it's I choose a lot of problems that need you to understand that technique. It's you use synthetic division when you're finding zeros. Usually 6 or 7 of the problems on next to the not the obviously the test you can already take midterm or the one next week, but the one after that. The 6 or 7 of the problems out of the 10 involve you have to know how to use this. The good part of it is it's the easier one. As we're going through this, if you don't understand where I'm getting the numbers, be sure to ask. It's not easy until it clicks with you. Once it clicks with you, you love it. You're wondering why you can't do anything with synthetic division or do everything with synthetic division. We're going to divide this by this. Our first step, you take what you're dividing by, which is x minus 2, you set it equal to 0. And then you want to solve it. So that gives us x equals 2. Our second step, you take the number you just found, and you put it in a box in the upper left-hand corner. You identify your largest power of x. Our largest power of x is x squared. So real small, I'm going to write x squared, x, and no x. You start with your largest power, and you have to have one for each power going down. The no x is our constant term. Don't make those big. If you make them big, you probably mess it up. You just want that small across the top. And then we're going to write down whatever number's in front of each one. We've got a 1 in front of the x squared. We've got a 3 in front of the x, and then our constant term is -7. Not necessarily where we're headed yet, but is there any questions on the setup? We're going to go through a series of adding and multiplying over and over until we're done. First thing we're going to do is add. We start with our first column here. We're going to add. We got 1, and then there's nothing here. 1 plus nothing is 1. You simply bring that 1 down from that first. And then you're going to multiply. You always multiply by a number up in the box, by a number you just put down here. So 2 times 1 is 2, and we put it over here. And then we want to add. 3 plus 2 is 5. And then you want to multiply. You always multiply by a number in the box, by a number we just put down here. 2 times 5 is 10. And then we want to add. -7 plus 10 is 3. How do you know when you're done? When there's no more columns. Now this was an x squared. Straight down below it will be 1 degree lower. That'll be an x. And once you have your first one, you have one for each one going down. So that's x. This is our no x, or a constant term. This will be our remainder. So our answer is going to be x plus 5 plus you put the remainder over what you're dividing by. And that's our answer. Questions on that? Let's take a look at this one. Okay, 9x squared minus 4x minus 3 divided by x minus 2. Again, first step is to take what we're dividing by, which is x minus 2, set it equal to 0, and solve it.
How do you know when this will work and when it won't?
If you're dividing by x plus a number or x minus a number, it will always work. That's a good question, because a lot of people think they try to do it on this one, where I'm dividing by 3x minus 2. Won't work because of the 3. Or if you're trying to divide by x squared minus 3, won't work because of the second power. So it is very, very specific when you can do it, but the good part of it is the problems dealing with zeros, you use it all the time. There's no question on it. Step 2, take the number that you just found, and I got a lot of these that say 2. I wasn't very original in coming up with the problems. And put it in the box in the upper left-hand corner. Identify your largest power, which is x squared. So across the top, I'm writing real small, x squared, x, and no x. And then write down each number that's in front of it. So we've got 9 here, -4, and -3. Now we'll go through a series of adding, multiplying over and over until we're done. 9 plus nothing is 9. Multiply. You always multiply by number in the box, but number you just put down there. 2 times 9 is 18. Put there. Add. -4 plus 18 is 14. Multiply. You always multiply by number in the box, by number you just put down there. 2 times 14 is 28. And then add. -3 plus 28 is 25. Now this was an x squared. Straight down below it will be 1 degree lower. That'll be an x. This is no x, or a constant term, and this is our remainder. So our answer is going to be 9x plus 14 plus 25 divided by what we're dividing by, which is x minus 2. Let's take a look at this problem. X to the 5th plus 3x to the 4th minus 4x squared plus x plus 2 divided by, I'm going to change that to x plus 1, just so it's something a little bit different. I do got an x plus 3 or x minus 3 here shortly, but unfortunately you used x plus 2 all over the place. Or x minus 2. Step 1, take what we're dividing by, set it equal to 0, and solve it. And so that gives us x equals -1. Step 2, take the number we just found, put it in a box in the upper left-hand corner. Identify our largest power, which is x to the fifth. So real small across the top, I'm going to write x to the fifth, x to the fourth, x to the third, x squared, x, and no x. So starting with the largest power, you have to add 1 power for each one going down. And then write down the number that's in front of each one. There's a 1 in front of the x to the fifth, a 3 in front of the x to the fourth. There is no x to the third, so we have to put a 0 there. -4, 1, and 2. By writing this real small across the top, make sure that it's always in standard form and it handles any missing powers for you. I'll get lazy here shortly and I'll quit putting that across the top. And then sometimes I screw up because I don't do that. So it's a good idea to always put it. Okay, so now we're going to add 1 plus nothing. Oops. Is 1. Then we multiply. You always multiply by number up in the box, by number you just put down there. -1 times 1 is -1. Then you add 3 minus 1 is 2. Multiply. Always multiply by number in the box, by number you put down there. -1 times 2 is -2. Add. 0 and -2 is -2. Multiply. -1 times -2 is a +2. Add. -4 plus 2 is -2. Multiply. 2 times -2, or wait, look at the 2 here. -1 times -2 is 2. Let's see if I got everything else right. Okay. -2 plus 2 is -2, +2. Okay, 1 plus 2 is 3. Multiply, add. Now this was x to the fifth. This will be 1 degree lower. This will be x to the fourth, x to the third, x squared, x, no x, and a remainder. So we're going to have x to the fourth plus 2x to the third minus 2x squared minus 2x plus 3 plus -1 over what we're dividing by, which is x plus 1. You can put the negative out in front if you wanted to, in front of that fraction, or on top like that. Different books do different things. Some want to emphasize specifically your remainder is a -1, not a positive. So that's why they'll put it up on top like that. This would be a hideous problem using long division, probably an entire page worth of work. Synthetic division takes all the variables out of there and squashes it together. So it's a very short way to do it. And you'll love it once it clicks with you. If it already hasn't. You might already know synthetic division when you came into the class. Is that true? They may not know it. Synthetic division. No? Let's take a look at this one. X squared minus 5x minus 2x to the third plus x to the fourth divided by 3 plus x. Okay, step 1. Take what we're dividing by, which is 3 plus x, set equal to 0 and solve it. So I take 3 over, it gives me -3. Step 2, take the number you just found, put in a box in the upper left-hand corner. Identify our largest power, which is x to the fourth. So real small across top, I'm right, x to the fourth, x to the third, x squared, x, and no x. And write down whatever number's in front of each one. There's a 1 in front of the x to the fourth. There's a -2 in front of the x to the third. There's a 1 in front of the x squared. There's a -5 in front of the x. And no x, the constant term, is missing, so we've got to put a 0 there. add, multiply, add, multiply, add, multiply, add, multiply, and add. Again, that just narrows it down just to basic math. Now this is x to the 4, so right straight down below it will be 1 degree lower. That'll be x to the 3rd. Then I have to have, after I have that one, I have one for each power going down. So x squared, x, no x, and a remainder. So our answer will be x to the 3rd minus 5x squared plus 16x minus 53 plus our remainder, which is 159 over what we're dividing by, which is x plus 3. I'm going to skip this next problem. I think you kind of got synthetic division. And let's go to the remainder theorem. I like to show this by example. Got f of x is equal to x to the 3rd minus 2x squared plus 3x minus 1. And we want to find f of 2. We got our old way. This is just evaluating the function. To find f of 2, it says you plug 2 in for your x. Two to the 3rd is 8, minus 2 squared is 4 times 2 is 8, plus 3 times 2, which is 6, minus 1. 8 minus 8 drops away, 6 minus 1 is 5. And so that'd be our answer. The new way is using something called the remainder theorem. Remainder theorem says you can use synthetic division to evaluate polynomial functions. It only applies to polynomial functions, doesn't apply to any other kind. And what you do is you take the number that you're evaluating for, which in this problem is a 2. You put it in the box in the upper left-hand corner. Identify our largest power, which is x to the 3rd. So again, we'll have an x to the 3rd, we'll have an x squared, x, and no x. That's 1, negative 2, 3, negative 1. Go through your adding and multiplying over and over until you're done. Add, multiply, add, multiply, add, multiply, add. Remember what this last number represents. That's your remainder. Notice how it matches that right there. The remainder theorem says you can use synthetic division to evaluate polynomial functions, and your remainder will be your answer. Same as if you'd done it the old way. Now, this doesn't have a whole lot of use, to be honest. It wasn't that hard to do it the old way. The new way doesn't seem to have much benefit for the remainder theorem. I think they're just giving you the direct example of where could you use synthetic division. And it gives you more practice, which is good. Now, next two problems really are the same, but this next problem, we're given f of x is equal to x to the third minus 3x squared minus 10x plus 24. Now, really, the instructions are at the very end of the problem. What our goal is we want to find all the zeros of f. So that's what we want to do. We saw that in the last section. To find all the zeros, you set it equal to 0 and solve it. So I said x to the third minus 3x squared minus 10x plus 24 equals 0. We're going to see in the next section, the fundamental theorem of algebra says your largest power tells you how many answers you're going to have. So the third power means we're going to have 3 answers. Now this doesn't factor though. So the other instructions they give you here is they're trying to give you a hint. They say use synthetic division to divide this by x minus 2. Well, let's do that. We'll take our x minus 2, set it equal to 0, and solve it, and we get x equals 2. Largest power is x to the third, so across the top I'll write x to the third, x squared, x, and no x. So we got 1, negative 3, negative 10, 24. I'll add 1 plus nothing is 1, multiply, 2 times 1 is 2, add, negative 3 and 2 is negative 1, multiply, 2 times negative 1 is negative 2, add, negative 10, negative 2 is negative 12, multiply, 2 times negative 12 is negative 24, add, 24 minus 24 is 0. The title of this section referred to the factor theorem also. We looked at the remainder theorem. If you're wondering what a theorem is, it just means some important concept that you can prove. And it says, specifically dealing with this process, if the remainder is 0, then you found an answer. Another name for answer, aka a 0. So if remainder is 0, it means you found an answer, also known as a 0. What that means is that whatever number's in this box right here is going to be our first answer. So x equals 2 is an answer. Now we started with x to the third. This is 1 degree lower. This will be x squared. This will be x. This will be no x. And we've already indicated that's our remainder. So we're left with x squared minus x minus 12 equal to 0. Why did I set equal to 0? I set equal to 0 because we're finding zeros. So you're constantly setting things equal to 0. Now at this point, this is something we can factor. This factors as x minus 4 times x plus 3. 0 factor property says I can set each factor equal to 0. And we get x equals 4 and x equals negative 3. And those will be our 3 answers. So we are given a hint on one of the answers. We plugged in synthetic division, found out it truly was an answer, and that took it down to the x squared level. Each answer you find through synthetic division takes it down one more power. Take a look at number 11. Got x to the third minus 3x squared minus 13x plus 15 equals 0. Now our largest power is x to the third, so degree is 3, means we're going to have 3 answers. That doesn't factor, but they give us a hint. They say given that negative 3 is a 0, so they give you an answer. Since they give you an answer, we can take that and we can plug that in synthetic division. Largest power is x to the third, so we'll have an x to the third, an x squared, an x, no x. 1, negative 3, negative 13, 15. That could have been bad. In my pot, I want to be able to take a drink here shortly. Add, multiply, negative 3 times 1 is negative 3. Add, multiply, add, multiply, add. Notice we get a zero's remainder. We should. If they tell you it's a 0, you have to get zero's remainder. But this right here confirms that x equals negative 3 is our first answer, our first 0. Now this was x to the third, so this is now 1 degree lower. So this will be x squared, x, no x. And we're left with x squared minus 6x plus 5 equals 0. Now this factor is using the PSD. Factors as x minus 1 times x minus 5. 0 factor property, set each factor equal to 0. And solve it. And you get x equals 1 and x equals 5. We said we're going to have 3 answers, and we have 3 answers circled. The next section is going to be all these type of problems, except for you won't be given the hints telling you what the answers are. You have to find out the answers via the calculator, which isn't hard. It's a blessing. Problems used to be hideous. One problem would take you 10 or 15 minutes to find the answer if it's big enough. Now the calculator does it for us. It really reduces the time. Okay. The midterm exam is on Wednesday. You can use 4 pages of notes, front and back. Essentially 8. Don't come in with 8 pages like singles, with one side, because I'm going to visually look to see if you have 4 pages. Can I use cell phones? There's nice websites that you can type in every answer off the test. It gives you or every question off the test. It gives you the answer. Ones you come in and take, you can't use your cell phone at all. If you have your cell phone out during the midterm or final, you'll get a 0 on it. Again, for that reason. You get an hour and 20 minutes, normal class time, and you have to come in for it. So if you're at a distance now, then you have to take it in class here. If you miss it, the makeup I come up for it would be a lot harder, so don't miss it unless you want to take a harder test. It won't be the same type.
Do you know how many questions it is? About?
No more than 20.
No more than 20.
Yeah, I think it's either 15 or 20, something like that. At the high schools, I'll send it to your coordinator, and you can take it on an off day. I can't proctor it over my eyes aren't good. That's little window. And most of the time when I look, I can barely see how many people are there. See, like when I'm looking at Argonia now, well, Argonia is easy. Udall, I have no clue. I think they're all asleep. No, just joking. But I couldn't tell you how many people are in Udall. So that's why I'll have your coordinator proctored, and whenever it's good for them, I'll work with you on that. So now the rest of the time, that's all I want to cover today. We finished that section. So the 2 sections we finished are 3.2 and 3.3. But the rest of the time is for questions, if you have any. If you don't have any, take off. And I'll see you on Wednesday, and we'll have the midterm then.
And the midterm is graded based on work, correct?
Correct.
So like even if I get the wrong answer, but it would work, and it looks like I was going the right direction, I can credit.
Yeah, each one's worth 10 points. And let's say you knew what you're doing. You just messed up on the sign.
Yeah.
Multiply -3 times 1, and you put down +3. You'd miss 2 points out of the 10.
Okay.
So.
So do people normally score okay on the midterms?
The midterm, not too bad. Final, they don't. Yeah, because there's no work I don't grade based on work, and it's either right or wrong. But when I grade based on work, unless you leave a lot of them blank. Correct. Midterm's 20%, and final's 20%.